Okay, which one? What you got? You have some? Yes. 23. Y equals the square root of x squared minus 1. Find the extreme values of the function. All right, so what do we need to do? Find the derivative. Is my domain restricted here at all? No, why? What's the only thing that happens with radicals? They have to stay what under the radical? Positive. Is this always going to stay positive? Greater than or equal to 0. In other words, is x squared minus 1 greater than or equal to 0 if I take, yes, because it's always going to be positive, right? No, what if I put 1/2 in? Then, right, then x squared is not bigger than or equal to 1, right? And that would give me a negative under. Do you see what I'm saying? So whenever I do this, I do have, I think this is what I was trying to explain to you earlier, Caroline, is I do actually have a domain restriction. I have an endpoint here that starts at 1. Does that make sense to you? The negative one doesn't really apply because bigger than 1, it's still got to be bigger anyway, but starting, does that make sense? Am I making, yes, no, maybe so. But couldn't at negative so I need to go, you're right. I need to go here. So my domain is like this. This is my not in domain part. Does that make sense? You're right. Because I got to do the plus or minus here. Right? The only thing that's going to give me undefined there is if under that radical I put a fraction. Right? Okay. Okay, now let's worry about derivative. What's the derivative here? Do power first. 1/2. Agree or disagree? Chain rule. So I really just have x over the square root of x squared minus 1. Bless you. Yeah, the 1 happened too. All right, what now? I was looking at what I'm looking ahead, and I thought I remembered seeing 0 in the answer written in blue under it, and I was like, 0 is not even in the domain. It can't be, but it's the minimum value of 0. Not anyway. Sorry. Okay, you're right. All right, so everything goes to 0. So x equals 0. Right, that's for the top. But again, that's not in my domain, so it really doesn't matter. Okay, so that's not going to impact me. Now, denominator equal to 0. Squared, x squared. Minus 1 equals 0, x equals, here's my plus or minus 1 again, right? You okay there? So really, on my sign chart, I'm just looking at negative 1 and 1, but I'm not counting any of this in between. You okay there? So this is derivative, actually use y. So here's derivative and function. All right, so positive or negative when I plug into the derivative here. That's going to give me a negative up top divided by, you're always squaring here and you're always bigger than 1, right? So the bottom's always going to be positive no matter what. So I'm really just looking at the sign at the top. So negative, which means I'm decreasing, right? And then bigger than 1, what's happening up top? Positive, so I'm positive, divided by positive, so I'm positive, so I'm increasing. So now the only thing left to do is to determine, I need to probably, what did it ask me? Did it ask me for value or, yep, find the extreme values of the function and where they occur. So I know I have a minimum occurring at -1 and at +1. Do you see why why they're both minimums, right? Because I'm starting out decreasing and then I stop and then I start increasing from wherever so they're both minimum values, relative minimum values, but minimum values nonetheless. And that's what they asked me for. Y'all okay there? So they asked me for the value. The value is the y, right? I know where they occur. I know they occur at x equals -1 and x equals 1, but I need to know what those values are. So I need y of -1 and I need y of 1. Go with me? Yeah, okay, just plugging in. All right, so it was square root of x squared minus 1, so 1 squared minus 1, so I get 0. I get 0 here as well. So I have minimum value of 0 occurring have 1 R or 2? I don't know. Does occurring have 1 R or 2? I think it's 1. I think it's 1 because there's 2 C's. Okay, I don't know. All right, occurring at x equals -1 and x equals 1 since they have the same value. There's 2? There's 2 minimum values? Oh, 2 R's. Yes. Is there really? Sure. They both look wrong. That's why English is stupid, math is better. Okay. 2. Okay. I trust you. Does that make sense on that one? What else? Tell me where the struggle is. Tell me what you're struggling with these. All of them after that? Is it finding the derivatives? Is it finding... Okay. And also realize these have got, because these are radicals, they also have domain restrictions too. So you do have some endpoints, some here as well. All right, let's look at 25. 25. Y equals 1 over the square root of 1 minus x squared. What shall I do first? Find the derivative. When in doubt, derive it. I'm going to make this 1 minus x squared to the -1/2, just to help me with power rule. -1/2, 1 minus x squared to the what? Paint it. Looks very similar to the last one we did. So x over 1 minus x squared to the 3 over 2. Or square root of 1 minus x squared cubed, whichever you want to do. All right, both to 0. So I'm looking for critical points here. X equals 0. 0, that goes away. 1 minus x squared equals 0. So plus 1. Is that what you just said? I'm sorry. Yeah. All right, so potential critical points here. Plus or minus 1 and 0. Agree, disagree, everybody okay? -1, 0, 1. What is it doing? Let's see. I'm squaring here. I'm doing 1 minus. All right, so if I'm negative, let's say -2. It is restricted. You're right, because I can't take the square root of a negative. 1 minus x squared cubed has got to be greater than or equal to 0. Flip, so I can't be, I'm undefined here, right? Past 1 this way, that's exactly right. Because if I put in, because it's square making it positive, that's right. So I am restricted this time. I have 2 endpoints, so that's nice. So now I'm, boom, boom, boom. So I'm looking at 3 potential points. So I am going to have to check endpoints here. Does everybody understand what I'm doing? Because I'm kind of talking through it as I, are y'all okay? For sure. Looking at domain restrictions of radicals, essentially, is what I'm doing as I go through and do the derivatives. Okay, let's test them. Is my derivative positive or negative in this interval? I got a negative divided by, because the x is always going to take the sign, right? Divided by what's happening here. If it's, let's say, -1/2, 1 minus a half is positive, and then whatever else I do with it is going to stay positive. So this is negative. Between 0 and 1, this down here is going to stay because I'm squaring the x. It's going to stay positive down there, right? And 1 minus a half is, of course, a positive number. But up top, I'm positive this time, so I'm positive. So I'm down, decreasing, then increasing. So I do have an absolute extreme point here, right? Or I should. And so to find them, we will have to test them. So now I do y of -1, I do y of 0, and I do y of 1. Original equation was 1 over the square root of 1 minus x squared. No, 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 no. Because it doesn't include the endpoints. So I can't test the endpoints. But, so all I can say is y of 0, find that value, which is 1 over the square root of 1 minus 0 squared, which is 1. All I can say is this function has a minimum value of 1 at x equals 0. I can't say the absolute because my endpoints are undefined. Does that make sense? Which number was this? Min value 1 at x equals 0. Yeah. That's right. Because they're undefined there. If you do that, you'll be divided by 0. So they're undefined, so I can't test them. Now, this would have to be a relative max coming in here, but it can't be at -1. And you can't really say negative 0.9999999. You know what I'm saying? So you wouldn't call it. You would just call the 0, x equals 0. But the function value is 1. It occurs at x equals 0. Y'all okay with that? Everybody good? Sure. I feel like y'all are like, eh. What'd you say, 27? Okay, 27. Whew, all these radicals. The radicals are there just to test your restricting of the domain. That's essentially what they're doing here. So I'm going to go ahead while I'm here and say that this has got to be greater than or equal to 0. Can I factor that? I'm going to go with yeah. X minus 3, x plus 1. What? Well, and I haven't done the derivative yet. I'm just thinking about my, is this a calculator problem or no? I'm looking at it. Breaking the law. I feel like y'all get so bored in here sometimes. I feel a little bad. Like I need to entertain y'all. It's what? Okay. Well, if y'all get bored, tell me because I feel like I feel like Ben Stein up here sometimes. Calculus is so different than everything else, so I can't really jump up and down and do factoring and stuff like I do in Algebra 2. Okay. I'm between -1 and 3. Those are the points here that I'm testing. So I need a derivative because I always need a derivative. 1/2, 3 plus 2x minus x squared, -1/2, and then chain it, 2 minus 2x. Ugh. All right, I'm going to take a 2 out of everything so I can cancel that 1/2 out. So I have 1 minus x over the square root of 3 plus 2x minus x. Well, this one's easy. And that is in my domain. Okay. And the bottom, we've already factored and found where it equals 0, so I still got my -1 and my 3. Everybody okay? Okay. So this time I can test, and here's why I can test here this time. Before it made the denominator 0, right? That radical was in the bottom, so it wasn't greater than or equal to 0, it was just greater than 0. Here, I'm just a radical that's greater than or equal to 0, so it can be 0, so it's okay to plug those values in. Now, if I plug these values in, what should I get? 0. That's what I solved for, right? Y of -1 should give me 0 because I solved for 0 over here. And y of 3 should also give me 0. Okay, so I'm going to need to find y of 1, and I'm going to need to look at the signs of my derivative to find out what my function is doing. All right, well, between 1 and -1, so maybe 0, what's the sign? Positive over positive. So it's always positive, so I'm this way. Between 1 and 3?
If you're going on the morning WTC tour, you can go ahead and head to the bus circle at this time.
Time. What is time? Huh? There has. They just keep doing it. Holy cow. Oh. I am because it helps me. It's a little bit easier for me to see. If I think about what's divided by what, because all I want is a sign. I don't need to know the actual value. So it's easy for me to think, okay, if this was 2, if x was 2, well, 1 minus 2 is a negative number. And then if I put in a 2 down here, 3 plus 4 would be 7 minus 4. I'm still positive, right? So that's going to be positive on the bottom. So negative divided by a positive is a negative, and I am decreasing. So I already know that x equals 1 is a maximum. I don't know if it is the maximum. It should be, but let's see. If I plug in here, I get the square root of 3 plus 2 minus 1, which is 5 minus 1, which is 4, which is 2. Therefore, that's bigger, right? Y has an absolute max of 2 at x equals 1. And you have to say why, because derivative goes from positive to negative at that point. I don't write this every time, but understand if they asked you to explain why this is your justification. This is why you have to tell. They used to say that this was enough justification and you could leave it. And recently they've changed and said no, they want you to be able to interpret your sign chart, which is dumb. So make sure you can explain that because the derivative changes signs from positive to negative, there's a maximum occurring, and whenever you test those endpoints and all. But this one also has minimums. I can also declare the minimums here since they're endpoints. So it also has, y has a minimum value of 0 at x equals -1 and x equals 3. What else? Okay. Y'all need a break? 29? Well, that's all the ones y'all have. Why? Oh, gross. Any domain restrictions here? Bottom can't be 0, but the bottom will never be 0, right? Because I'm squaring x. So no domain restrictions here, so I'm good to go there. So let's find a stinking derivative here. What'd y'all do? Quotient? Product? Quotient? Quotient it is then. You did product. All right, derivative of the top times the bottom minus the top times the bottom all over bottom square. So this is 2x squared, so I have negative x squared plus 1 over x squared plus 1 squared. This to 0 would give me plus or minus 1. This to 0, that's never going to work, right? It's never going to be 0. So I'm only looking at plus or minus 1. Looking at the derivative to tell what the function is doing. So let's see what happens. -2. This negative is going to overpower. That's going to trump everything else in the end. So what I'm saying is no matter what you plug in here, this is going to be negative, right? So if I plug in -2, -2 squared is 4, but then I'm going to make it positive. So up top, I'm going to be negative. On the bottom on all of these is going to be positive because I'm squaring, right? All right, so here I'm negative. At 0, I'm positive. And bigger than that, I'm going to be negative. I have a minimum occurring at x equals -1, a maximum occurring at x equals 1, but they did ask me for the values of the function, so I need y of -1 and I need y of 1. Y of -1 would be -1 over -1 squared plus 1, which is -1/2. And y of 1 would be 1 over 1 squared plus 1, which is positive 1/2. So minimum value of -1/2 at x equals -1, maximum value of 1/2 at x equals 1. That one was easier than the old. Y'all good? Do you need more practice on EVT or do you want to move on to the next thing? Yeah. Oh, a trig function. Sine of x plus pi over 4 between 0 and 7 pi over 4. Where's 7 pi over 4? Do what? Which quadrant? That's right. So I'm going from 0 all the way around to here. All right. I do have endpoints, so let's set them up. 0, 7 pi over 4. All right. Derivative. Do the trig first, followed by the chain. That's it. Change just one. Right? So where is this 0? So you really got to kind of think about this. So let's think about our unit circle. Cosine is 0 on the axis, right? No, up top and at the bottom. So how is x plus pi over 4 going to give me pi over 2? Right? Subtract it. So x needs to be, is that what y'all got? There's another one though, right? Look down at the bottom. Cosine is also 0 there, right? So I need this to be also 3 pi over 2. So what does x need to be? 5 pi over 4. Okay, so on my unit circle, cosine is 0 at 2 places. Pi over 2 and 3 pi over 2, right? Those are the only places on there where cosine is 0. So what I did was I said, okay, what would I need to plug in for x in order for this whole parentheses to be pi over 2? And then what would I need to plug in for x in order for this parentheses to be 3 pi over 2? Because cosine of 3 pi over 2 is 0, and cosine of pi over 2 is 0. So I had to figure out what would x need to be to make that happen, because those are the only 2 places it happens. All right, so I have my zeros. I have my derivative. Now I need to test the derivative to see what the function's doing. And I'm going to have to test the endpoints, which stinks. Let's do sines though. Okay, between 0 and pi over 4. What's the sine of cosine? All right, so I'm doing, what I'm really going between is, if I plug in here, I'm really going between pi over 4 and pi over 2. What's the sign of cosine there? Positive or negative? Well, so I'm looking at my derivative, okay? So let's, between 0 and pi, what's a value between 0 and pi over 4? Pi over 6? Okay. If you plug pi over 6 in here for x, is cosine going to be positive or negative? So cosine of pi over 6 plus pi over 4 plus pi over 6 plus pi over 4 for 10 pi over 24, which is 5 over 12. Where's that? Where would that be? I'm still in the first quadrant. That's what I'm trying to get to. That's what I'm trying to get y'all to anyway. I'm still in the first quadrant here. Say that again. No, I don't look like that. So it's not on your unit circle. Okay, so let me explain it this way. All right, so your derivative is cosine of x plus pi over 4, right? And my x is between 0 and pi over 4. You agree? So between 0 and pi over 4 is from here to here, right? If I move this whole piece here plus another pi over 4, I'm still in the first quadrant, right? So cosine is still positive. But now if I go between pi over 4 and 5 pi over 4, but I click everybody over a pi over 4, well, I'm suddenly from here to here. And cosine is what there? Negative. That whole side is negative there. Come down. And then between 5 pi over 4, which is here, I'm looking at it backwards, I'm trying to see it through the paper, and 7 pi over 4, but I click it over pi over 4, right? So now I am from here to here. What is cosine? Positive. That was a little bit tough, right? Because I'm adding pi over 4. All right, so now let's test the point. So I need f of 0. I need f of pi over 4. I need f of 5 pi over 4. And I need f of 7 pi over 4. And I'm sine x plus pi over 4. So sine x plus pi over 4, sine of pi over 4 plus pi over 4 is pi over 2. Or 9 pi over 4. Is that not right? What am I adding? I added pi over 2. What? Stop doing that crazy math. Did I mess up on this one too? Pi over 4 plus pi over 4. It's 2 pi over 4, which is pi over 2. That's right. All right, plus pi over 4, which is 6 pi over 4, which is 3 pi over 2. Oh. Plus pi over 4 is 8 pi, which is 2 pi. Sine of pi over 4 is what? Y'all should know that one. Square 2 over 2. Sine of pi over 2. 1. Sine of 3 pi over 2. Sine of 2 pi. Minimum. Where's your maximum? Is it 1 or is it square root 2 over 2? You'd have to be square root of 4 over 2 to get to 1. I promise whenever I finish this one. This is 42. I've got this piecewise. We're not going to worry about identifying which critical points are not stationary. We're just going to find the critical points and determine their local values. All right, y equals. Remember, not only am I testing zeros, but I also test what? Points of discontinuity or non-differentiability. Great day in the morning. Where should we start with this? Yeah, well, this is the same thing, but I'm just gonna. This is one. Sorry. What shall I do? Derivatives. Let's go with derivatives. I don't know. Let's go with derivatives. Derivative here. Negative 1/2 x minus a half. Bless you. When x is less than or equal to 1. Three x squared minus 12x. This had an 8 on it. I mean an x on it. Plus 8. X is greater than 1. Bless you. My first question to you is this function even continuous at 1? How do I know? You got to plug in and see, right? I need to plug in 1 to each of these and see if it works, because these are polynomials. So you tell me, is it continuous, yes or no? It doesn't look like it would be. Negative 1/4 minus a half plus 15/4. If I plug in 1. Negative 1/4 minus a half is what? Negative 3/4. Negative 3/4 plus 15/4. Here I get 1 minus 6 plus 8. Negative 5 plus 8. Well, imagine that. Limit from the left is same from the limit as the limit from the right, which is the same as the function value. So it is continuous, right? Continuous and differentiable, but I still need to check these points to see if the sign is changing or not at these points. So, because these are potential critical points, right? Even though it is continuous. Okay. So now, so what I'm getting at is when I'm piecewise, I already know that I'm going to have 1 on mine, because that's my point of something potentially happening there, going from one function to the other, even though I know it's continuous. All right, so now I need to know, here's where the fun starts. Now I need to know where my function equals 0, right? Okay, where does, let's do derivatives equal to 0. Where does this 0? -1. That one's easy, right? -1. But I also have to do my second equation equal to 0. So I also have to do 3x squared. Now here's where I said the fun was fixing to come in. Guess what? Does not factor. What multiplies to 24x squared but adds to -12? Nothing. What does that mean?
I don't even remember it.
You're telling a story, Avery.
No, this video on the essay, I was literally like trying to fix my song in my head, and I was like, something's not right.
Okay, nothing to it but do it. Opposite B. You want me to write it out for you? Okay. Opposite B plus or minus the square root of B squared, so that's 144, minus 4 times A times C all over 2A. Oh no. 96 was 144 minus 96. That would be 44. Don't tell me 48. Is that right? Look at me and my mental math. I'm gonna clean it up just a tad. 16 and 3. Bigger because you got a 12. 16, right?
Oh, wait, what?
What do you divide 48 by? 16 times 3 is 48, isn't it? Yeah. So 4 root 3. 4 and 12. You could do 4 and 12. You get 2 root 12, but then you have to do 12 again.
Why?
I did 16 and 3. So I did 48 is 16 and 3.
And then divide.
And now I can simplify. I can divide everybody by 2. 2 root 3 over 3. Okay. I need to know approximately what these are going to be. A little bit bigger than, let's see, that'll be 2 plus 2 to around a little bit more than 3, getting close to 4, maybe. Is that right? A little more than 3, because that would be 2 plus. Almost 4. I don't know. If you have your calculator, I don't know. It's definitely going to be over here though. 6 plus 2 root 3. I'm assuming this is a calculator problem, or is it not? It's not. Holy potatoes. No, you're right. Okay. So the negative is going to be over here. That's not going to, no, because this is bigger than 1, so that's not going to impact. That's right. All right, so I don't have to include the negative one, the minus one. Did y'all see why? Look at that restriction. It says x has got to be bigger than 1, so I'm not going to be smaller than 1. That's smaller than 1. Now to test them. This one just had to be, yeah. That's okay. All right, here's my derivative, here's my function. Isn't this fun, y'all? No. This one's a little... Grace just trying to make me feel good. I appreciate you. Thanks. All right, smaller than -1, so I'm plugging into this equation. That's a great one to plug into. Positive or negative? I believe. There you go. Between -1 and 1, so 0. It's an easy one. It's negative. Between 1 and... Well, that is gross. So maybe 2. Well, because this is 3 something. Yeah, so around 2.
3 something.
It's awful. I hope it's... Is it negative again?
1.5.
Okay, so since this is bigger than 1, I've now moved to this equation. It's negative. Feel good about that, Henry? It's negative. It does. So think about something like a cubic that would come in and kind of do that. It never actually has a critical point, but it's something like that. All right, how about bigger? I hope it's positive. Well, if I get really, really big and I'm squaring it and times it by 3, I think that's probably going to overtake the rest of this, but I don't know. But yeah, like 4 or 10 or 100 or anything. It should be positive. I don't see the answer for this one. This is what I got whenever I worked it out. 42. Nope, there's 45. Okay, so this one didn't ask me. Oh, it did ask for the extreme values. Holy crap! Oh, but we don't. Well, but we're plugging in. So I would need to. I don't have endpoints. So I've got a max at x equals -1. I'm gonna say a max of whatever that is whenever you plug it in. And a minimum of, so you can't count this one as a minimum, even though it comes down, because then it's still going down, right? So it's a minimum of whatever you get whenever you plug this in at x equals. Be very careful about what equation you're using to plug in, though, because if I'm at -1 here, that means I am using the first equation. And if I'm at here, then I'm using the second equation whenever I plug in. I'm going to shut up and stop. I talked way too long. We'll do the evens to your odds last night. Practice. So we'll do 12 through 30 even. What's that for? I want you to do a piecewise too. See what happens. It won't be as hard as the one I did. Let's do 39 and 41. And we'll do MVT tomorrow. That'll be fun.